Welcome to this explainer. Today we're decoding the 1977 WOW signal. We are diving straight into what is, hands down, the most famous and, honestly, the most baffling anomaly in astronomical history. For nearly half a century, this one fleeting burst of radio waves has completely captured our imaginations. It's like the ultimate cosmic mystery. But to really understand what went down and what modern science is finally revealing about it, we've got to look directly at the data itself.
So what did a 1977 computer printout actually reveal? I want you to picture this. It's August 1977. You're an astronomer sitting in a completely quiet observatory, poring over stacks and stacks of continuous paper printouts from a massive radio telescope. You know the drill. Day in and day out, you're mostly just staring at the baseline static of the universe, just that quiet hum of empty space. What on earth could possibly make a seasoned researcher stop dead in their tracks, grab a red pen, and frantically scribble a note right on the page?
What was exactly this? On August 15, 1977, the Big Ear radio telescope at Ohio State picked up an unbelievably strong narrowband radio signal. A couple of days later, astronomer Jerry Ehman is reviewing this exact printout, and he spots a highly unusual sequence of characters, 6EQJ5. He circled it in bright red ink, wrote WOW in the margin, and the name just stuck instantly. It's actually wild to think that this simple, heavily pixelated string of letters and numbers has fueled decades of intense scientific speculation. I mean, it literally inspired everything from targeted SETI searches to endless late-night internet debates.
Anatomy of the signal. Let's break down the exact mechanics of this detection, because we really need to understand why this was so baffling. Was it just a random spike in terrestrial noise, or maybe a hardware glitch? Well, the signal actually possessed several highly specific traits that perfectly mimicked what researchers thought an intentional extraterrestrial broadcast would look like crossing the vast expanse of interstellar space.
First up is the duration, exactly 72 seconds. You see, the Big Ear was a stationary transit telescope. It didn't physically swing its massive dishes across the sky to track things. Instead, it just stared at a fixed altitude and let the Earth's natural rotation do the work, carrying the night sky through its observation beam. Because of the exact width of that observation window, a fixed point in the deep sky would take exactly 72 seconds to drift through the telescope's focus. The WOW signal lasted for that entire 72-second window. It started quiet, peaked perfectly at the 36-second mark right when the source would have been dead center, and smoothly faded away. It behaved exactly like a true celestial point source, sitting way out beyond our solar system.
Then there's the frequency, 1420 megahertz. This isn't just some random spot on the radio dial, guys. This is the exact natural emission line of neutral hydrogen. Why is that a big deal? Well, back in 1959, physicists pointed out that since hydrogen is the most abundant element in the entire universe, 1420 megahertz would be the logical, universal watering hole for interstellar communication. It's a quiet, universally recognized channel where civilizations might try to reach out. It's actually so significant that it's a protected frequency band down here on Earth, making accidental human interference super unlikely.
Now, what's really interesting is how we decode that famous 6EQJ5 alphanumerical scale. The computer measured signal intensity using a pretty clever space-saving system. Numbers 1 through 9 represented standard deviations above the normal background noise of space. But once the intensity hit 10, the computer switched to letters. So A is 10, B is 11, and so on. The peak of the WOW signal was the letter U. Following that logic, the U means this signal hit an astonishing 30 standard deviations above the background noise. Statistically speaking, that is just astronomically rare. It was unbelievably loud against the quiet backdrop of the cosmos.
The Big Ear's blind spots. So we've got a loud, perfectly shaped signal on a protected, highly significant frequency. Case closed, right? Not quite. To get the full picture, we have to look at the physical design of the observatory itself, which had some unique mechanical quirks that make pinning down the signal's exact origin incredibly tricky. And this brilliantly illustrates the core of the problem. The telescope utilized a dual-beam system. It had two massive feed horns pointing at slightly offset directions in the sky, specifically in the Sagittarius constellation. This setup was actually designed to help cancel out terrestrial radio interference by comparing the two feeds. But here's the catch. A signal was definitely detected, but because of how the data was processed and recorded at the time, it's completely impossible to know which of those two feed horns actually caught it. So we are left with two distinct, parallel regions of the sky, each packed with thousands of stars, and absolutely no way to narrow it down to just one.
And that dual beam system creates an even deeper mystery, the one-beam paradox.
See, because the two beams were offset, they scanned at the exact same strip of the sky just a few minutes apart. A true continuous celestial object should have passed through the first beam and then roughly 3 minutes later popped up in the second beam. However, the WOW signal only appeared once. It hit one beam and completely missed the other, meaning whatever produced this massive burst of energy mysteriously switched on right as the beam hit it or switched off completely mid-transit.
Debunking the alien hype. Because the signal just vanished and was never found again, despite hundreds of really rigorous follow-up sweeps, it's super easy to jump straight to the alien broadcast hypothesis. But as curious observers, we have to look impartially at the data. Exploring the natural, scientific attempts to explain this anomaly actually gives us a totally different and maybe even more fascinating perspective on our universe.
Over the years, scientists have pitched a few natural explanations. For instance, in 2017, a comet hypothesis got pretty popular, suggesting two passing comets caused it with their massive hydrogen clouds. But the wider scientific community largely dismissed that. Comets just don't emit strongly enough at 1420 MHz to hit a massive U on the intensity scale. Plus, a slow-moving comet completely fails to explain that sudden one-beam paradox we just talked about. On the flip side, a much more plausible modern theory is that Big Ear was detecting a very early example of a fast radio burst, a localized, naturally occurring, transient astrophysical event that blasts out an immense pulse of radio waves.
The super radiance breakthrough. Okay, let's dive right into this because this is where the story gets a massive modern update. Archival survey data from Arecibo has given us an incredible breakthrough. In late 2024 and early 2025, a research team led by Abel Mendez analyzed historical data with modern analytical tools, and they proposed an astrophysical source for the signal that actually fits all of those bizarre contradictory criteria. They introduced a mechanism known as a maser flare, or superradiance. This is a sudden, intense amplification of a signal from a cold hydrogen cloud, triggered by a highly energetic source. In really simple terms, think of it like a giant cosmic laser. The cold hydrogen cloud floating out in deep space doesn't just glow at this incredible intensity on its own. It has to be triggered, or pumped with energy, by an insanely energetic, transient source sitting directly behind it in our line of sight.
Let's walk through exactly how this natural chain of events unfolds. Step 1. An intense, short-lived radiation source goes off, like a massive flare from a highly magnetic neutron star, a magnetar. Step 2. That giant pulse of energy travels through space and slams right into a diffuse cold hydrogen cloud sitting in our galaxy. Step 3. The cloud absorbs all that energy and essentially acts as a massive cosmic amplifier, triggering a sudden, blinding, super-radiant emission directly on that 1420 MHz hydrogen line. And finally, Step 4. As the underlying magnetar flare stops, the hydrogen cloud's emission just abruptly fades away. This process perfectly mimics the WOW signal. It beautifully explains the sheer volume, the exact frequency, and exactly why it only hit a single telescope beam before vanishing forever.
What are we missing? Whether the WOW signal was a rare, super radiant maser flare or something else entirely, its very existence forces us to confront a slightly uncomfortable truth about our place in the universe, and more specifically, about the vast limits of our own observational capacity.
So the crucial point here is captured brilliantly in a recent SETI discussion. They noted the lack of repetition isn't evidence of rarity, it's evidence of how little we've actually looked. It's so easy to look at the WOW signal and say, well, we never heard it again, so it must just be a meaningless one-off. But the reality is, telescopes like Big Ear were staring at microscopic slivers of the night sky for mere seconds at a time. It is literally like checking a security camera for one single minute out of an entire year and concluding that nothing ever happens in that room.
The WOW signal, at its core, doesn't definitively prove the existence of extraterrestrial intelligence, but it sure isn't just literal noise either. What it proves is how incredibly vast, energetic, and dynamic the radio sky truly is, and how historically limited our resources have been to map it continuously. I mean, if we had such a tiny observational window, and yet we still managed to catch a 30 sigma anomaly that we're still obsessing over 50 years later, what else is waiting in the dark while we aren't looking? Keep that question in mind the next time you look up at the night sky. Thanks so much for joining me on this explainer, and keep staying curious.